So far, everything we've looked at has been able to factor. So we'll now consider the case where we have an irreducible factor, ax squared plus bx plus c, in the denominator. In this case, my partial fraction decomposition will contain a term of the form ax plus b over ax squared plus bx plus c. So since we have an irreducible x squared in the denominator, we'll need to decrease that power by 1 for the numerator to get ax plus b. So we'll look at this example. This is already factored for us. So I have x squared minus 29x plus 5 over x minus 4 squared, x squared plus 3. So we'll first deal with this x minus 4 squared using the same method that we used on the last one. A over x minus 4 plus b over x minus 4 squared. We also need a cx plus d for this final term since we cannot factor x squared plus 3. So now we'll multiply by the denominator. X minus 4 squared, x squared plus 3. This gives us x squared minus 29x plus 5 is equal to a x minus 4, x squared plus 3, plus b, x squared plus 3, plus cx plus d times x minus 4 squared. If I let x equal to 4 on the left-hand side, I have negative 95. On the right-hand side, I have 4 squared, which is 16, plus 3, which is 19b. And you'll see that a and the cx plus d terms cancel. Dividing by 19 gives me that b is negative 5. And you'll notice I can't stick in anything else nice since x squared plus 3 doesn't have any nice zeros. So we'll go ahead and start multiplying things out. This right-hand side is a x cubed minus 4ax squared plus 3ax minus 12a plus bx squared plus 3b plus, and this part will be a little bit more confusing, x minus 4 squared is x squared minus 4x, or sorry, not minus 4x, minus 8x plus 16 times the cx plus d. So we get cx cubed minus 8 cx squared plus 16 times cx plus dx squared minus 8 dx plus 16d. So we'll regroup this. We have an a cubed and a c cubed. For squareds, I have negative 4a plus b minus 8c plus d, x squared. In front of x's, I have a 3a plus 16c minus 8d. And then for my constant terms, I have a negative 12a plus 3b plus 16d. So we now need to set coefficients equal. On the left, there's no x cubed, so the coefficient would be 0. On the right, I have a plus c. On the left, in front of x squared is 1. On the right, I have negative 4a plus b minus 8c plus d On the left, in front of an x, I have a negative 29. On the right, I have 3a plus 16c minus 8d. And then the constant on the left is 5. And on the right, negative 12a plus 3b plus 16d. And at this point, we'll need to solve the system of equations, keeping in mind that we already know b. And when you solve this, you get that a is 1, c is negative 1, and d is 2. We'll now look at trying to integrate this. So we'll break it up based on our partial fraction decomposition, which said 1 over x minus 4 dx minus 5 over x minus 4 squared dx plus negative x plus 2 over x squared plus 3 dx. For my first two problems here, I'm going to let u be equal to x minus 4, so du is dx. This gives me the integral of 1 over u du minus 5 times the integral of 1 over u squared du. So this is ln of u plus 5 of 1 over u. So ln of x minus 4 plus 5 over x minus 4. However, this last integral is a little bit trickier. We will actually do this one by rewriting it as the integral of x over x squared plus 3 plus the integral of 2 over x plus 3. So this first integral here, I'm going to let u be equal to x squared plus 3. So du is 2x dx. However, since I only have an x in the problem, I'll divide both sides by 2. So this is minus 1/2 times the integral of 1 over u du, which would be minus 1/2 ln of my new u, so minus 1/2 ln of x squared plus 3. This second part actually does require a trig substitution. And when we do that, we get 2 over the square root of 3 inverse tangent of x over the square root of 3 plus c.